So my name is James Brown. I'm a director of Alert Logic, which we kind of like to joke is the largest security company that no one's ever heard of. And hopefully by the end of today we can explain what we do and also at the same time really talk about how we see DevOps as something to improve security. And the reason why we kind of started down this track is that you spoke to lots of people who, to be honest, were terrified about DevOps. So in the security world, they just think it's a bunch of developers running wild. So we tend to do a fair amount of education around saying, no, DevOps is not a bunch of developers running wild. Actually, it's a man in remote control. Actually, it's giving you far more consistent and repeatable processes, which in the security world are just worth their weight in gold. So what I'm going to do is I'm going to see what happens. Oh, he's turning the volume down. I was hoping it was just going to magically appear there, but no. Okay, so let's kick this off by saying, what is the state of security in the cloud? So I used to work for AWS. I worked there for 2 years. I left AWS about 15 months ago. And what was interesting over those 2 years, we started in the camp of the cloud is completely insecure and we're never going to put any workloads on there, all the way through to now where we are saying actually those people have started to be quiet. They're now very much the minority. The cloud is being seen as something that you can put very secure workloads on, as long as you do it right. The sort of slight issue that we have is in that pendulum swing, we've gone from the cloud isn't secure to the cloud's completely secure and I don't have to worry about it. Okay, so this is part of what we need to talk to you about of saying, okay, there are still aspects of this you need to be concerned about. So security is still and has been ever since these graphs first started around cloud computing being the number one issue that people have, the number one pain point. It's the biggest blocker for getting into the cloud. You can throw endless surveys of this and they generally all come out with security at the top. However, the reality is done correctly, the cloud can be way more secure than anything you'll ever get on premise, especially if you combine it with things like DevOps. We're seeing a lot of people as they move to the cloud, not just to re-platform their infrastructure, but also to reintroduce new techniques and tools like Chef and DevOps to actually improve their development life cycle. The interesting thing that we see, we've been around for 13 years now. And so if you know the likes of Rackspace, DataPipe, SunGuard, Peer 1, Pulsant, Navisite, all of that lot, the reality is for their security services, behind the scenes, they all use Alert Logic. So those guys don't want to hire security professionals. They don't want to buy expensive tools. So they're all using us. We deliver security as a service to most of the major managed service providers. So only in the last couple of years, we were effectively really starting to sell this directly, which is the reason why it gets very interesting with cloud. So we have a very good view. We've got, I think it's now 3,800 customers. So we see everything from really on-prem through to kind of virtualized environments through into the cloud. We see different attack vectors being used, mainly because actually if you're trying to attack the cloud, malware and botnets start to become less useful. The reason why the way people target on-prem is that you send your IT guys some phishing emails, you ultimately get some malware on his laptop, and one day he will go plug that into his network. At which point you can now get onto the servers and you can start doing things. That becomes very difficult in the AWS world because you're not plugging anything into those networks. What we do see is a prevalence of web application attacks. Now this does not mean that the cloud is less secure when it comes to web application attacks. What it means is there's a significant majority of sites up there are running web apps, and to be honest, hackers go and take the path of least resistance. And therefore, web application tends to be the piece that's attacked most within that. We're also seeing these attacks becoming more complex. We were doing a webinar with the great and the good of the security industry, and one of them came up with this great phrase. You know, advanced persistent threats? Have you heard about this terminology in the security world? He was saying it's not really advanced persistent threats anymore. It's actually just average persistent threats. All it really means is someone's coming back after you. And we'll go through this in a bit, how you kind of wind up being on somebody's list to hack. And therefore, they are becoming more complex. And the reality is, as a hacker, my My time's very valuable. I want to maximize it because in my other time I'm watching Game of Thrones. So if I'm doing something, I want to make sure it works. So therefore, they just go for the path of least resistance. And when you hit AWS, if I have a choice between trying to hack in through the AWS network infrastructure or hack in through your website, it's your website every single day because it's just far easier than trying to get through the AWS security. This is the key thing, and AWS say this, and I said it when I worked there, and we say this again, but you really have to understand it, because AWS particularly, and not particularly, I mean, Azure does a similar job, they all do an incredibly good job at securing what they are responsible for. The key bit in that sentence was the bit that they are responsible for, okay? You try hacking into Azure's network infrastructure or backbone or AWS, good luck. You know, really, honestly, good luck. However, they are not responsible for your applications. They are not watching the network traffic that comes into your applications. I can sit here and craft up malware and SQL injections and cross-site scriptings all day, and that's not within their responsibility. So you have to understand that it sits with you. And what we find sometimes surprising, we go and see very large enterprises who are using AWS. They obviously have significant amount of on-prem, and they will list the security technologies they're using on-prem. They'll sit there and go, yeah, we do log correlation, we've got antivirus in there, we've got web application firewalls, intrusion detection, and then you go, that's great, so what are you doing in AWS? And they go, security groups and VPCs, really. All you've done is designed a secure network infrastructure. The other piece that sits in your responsibility is absolutely the apps. So CTO of Time stood up at, I think it was the San Francisco Summit, it was somewhere warmer than this anyway, stood up at the San Francisco Summit, and they said, look, because they're one of our customers, and they said, look, the thing is, AWS give you incredible physical and network security, but the app's all yours. AWS don't know what you're doing in your app. They don't protect it. They can't be expected to protect it. So this is where this pendulum swinging between the cloud is insecure and where we are now. We kind of need to come back a little bit. The cloud is secure, but you need to understand what your responsibility is. So it's key to keep an eye on the things like the applications. So traditional security tools really struggle in cloud, and for some security systems traditionally really like everything to stay the same, and especially things like IP addresses. They get really narky if IP address change. So you go to the cloud and they haven't got a hope because everything's changing very rapidly. IP addresses will change and so forth. So they really struggle with that. They struggle with there's no span port on a network switch to tap into. There's no firewall to go and tap into. Likewise, things like auto-scaling, befuddles and bemuses them tremendously. And also, it comes at odds. If you think about the traditional security approach, it really sits at odds with things like DevOps. A traditional security approach is literally having a checkbox. It'll be an Excel spreadsheet that they're checking. You try doing that with auto-scaling. I mean, that's a hiding for nothing, isn't it? You're never going to catch up. So what we're finding is that actually security teams are just being bypassed. And we speak to a number of enterprises who just sit there and go, well, we had a directive to get onto the cloud, we've had to do it, the security team can't keep up, and now we're stuck. Because now we've launched things into the cloud, and we know we don't have the sort of security pieces in there. And this is the problem, it just gets marginalized. They're just being shoved out of the game. They're used to turning around security reviews in a month or 2 weeks. I mean, who's been through a sort of full-on security review within an infrastructure application? They take weeks, and it just doesn't fit with the whole DevOps way of looking at things. So we did a survey quite recently around customers who are using DevOps as part of their practice. I'm obviously just doing this to keep my throat moist. And the slightly sort of scary piece that was in there was things like they're saying, actually, when you looked at the communication between DevOps and security and compliance, 70% of people are saying, yeah, no, communication sucks. 77 admitted to not implementing security into their processes. DevOps is fantastic. You've got something repeatable and you can improve on that. Every time you push it out, you can improve it. The reality is that people are not doing the same with security. Security is being left behind. And when you think about the shared security model, that could put you at risk. You can be more secure in the cloud. And this is royally nicked off Chef, so thanks for this. I love this slide. I do say it's you every time, and we left your name on everything. So this was a great example of saying, okay, so this was, Shell Shock. I was about to ask them because it's their slide, but it's on it. This was Shell Shock. So Shell Shock came out. Chef was halfway through, so not halfway, they'd started working with an enterprise. 2,200 servers on Chef, 60,000 servers not migrated to Chef. When you start looking at how quickly they can respond, 10 minutes for systems to report the vulnerability, an hour work needed to create cookbooks, and 10 minutes to patch all the servers. That's a lunch break. I mean, 8 hours, 144 days, and 5 days. I mean, hell, that's a sabbatical. That's not even a vacation. So this is where, especially in the security world changes really fast. If you think you can keep in front of all the vulnerabilities, you never will. That's why they're called 0 day. No one's ever heard of them before. So what you're judged on is the speed at which you can react. So you had Shell Shock first, Heartbleed first, and then Shell Shock. When Shell Shock came out, we were talking to some CTOs saying, well, this must be a nightmare for you because you've only just got over Heartbleed. And they replied, you're assuming we've got over Heartbleed. No, not quite yet. I saw some stats the other day on the internet of the amount of servers still out there vulnerable to Shell Shock and Heartbleed. So half the security game is actually the speed at which you can respond, and that's a game where DevOps is hugely powerful. So you need to start integrating this into the DevOps lifecycle. You really do. So quick question here: who has a security development lifecycle? Come on, there must be someone. Okay, guys, you really, so security development, you need to start getting security practices into your development. You need to start getting security practices into the way you roll this out. The world is changing and changing rapidly. I won't go through these. We did a blog, and it kind of went through a number of different things of saying, actually, okay, as a starter for 10, go away and look at these 10 things and try and kick off a project around each one of these of how you can improve it. It's small steps, but small steps can make a huge difference. Because I hate to say, the old gag, there's two missionaries in the jungle, and one's going out running every day. And the guy turns around and goes, why are you running every day? And he went, well, I'm worried about lions. And he went, well, yeah, but if we get a lion, they can outrun you. And he went, yeah, but all I have to do is outrun you, mate. And that's a bit like that with security. You just have to look more secure than the people next door, and they'll pick on the people next door. As I said, they're busy either hacking or watching Game of Thrones. They're not going to spend more time on you. They're just going to go to the weaker link. So what is there to worry about? Okay, so crime has always been risk versus reward. It's very, very simple. It's that equation has held true since the dawn of time. So in this day and age, putting a balaclava on, getting a sawn-off shotgun, and walking into a bank is really dumb. It's really dumb, okay? For a start, you don't actually get away with much money. The old films with the whole bags full of cash, now that doesn't happen. It's just what's in the tills, time-controlled safes. You're going to get away with about 5,000 to 10,000 quid. You've also got a capture rate of something around 50%. I mean, it's really, the odds are not good. Apart from Hatton Garden Heights, that seems to be going quite well. But the odds are really bad when you start looking at bank robbing. And to be honest, these people don't really care. Okay, do you really think these criminal gangs care of what they do? Do they sit there and go, do you know what, I much prefer running drugs. I've never been into this protection racket. They don't. They just pick the risk versus reward. Cybercrime could become more lucrative than drugs. So what we're seeing is criminal gangs actually bringing cybercrime in the same way as, remember the old days you see the films, two big guys walk into a shop and go, unless you give us £500, we're going to throw bricks through your window. It's a protection racket. It's as old as, as old as crime has ever been. Nowadays, they just turn up and they go, okay, so 500 quid or I take your website out. What do you want? They're just moving online. These guys, they're not picky. And the capture rate in cybercrime is abysmal. I mean, it's terrible. You're talking like 0.0% of people are being caught. So they're just going to pick the sort of the less risky ones. And this is the bit that I love. So on here, I don't know whether you can see it. So organized cyber groups are now as powerful as nations. So you hear about this nation state hacking. The reality is some of these cyber crime groups are actually at about that kind of level. But this is what is best with crime as a service. There we are, infrastructure as a service, platform as a service, and crime as a service. Because if you think the Cray twins would actually be learning like JavaScript and Python, you're kidding me. No, they will just buy those services from somebody, generally in a different country, because then you try capturing them, they're over in a country you have no jurisdiction in. So these criminal gangs are actually buying services on the internet, and there's an entire ecosystem. You know, I will write a hacking tool, but I would never, ever hack anyone, but I'll happily sell it to you for $20,000. And then somebody will go and collect a whole bunch of credit cards. We go, I would never actually do anything with these credit cards, but I'll sell them on an auction site. So you know on tour, there's auction sites for credit cards. Price goes up and down, you can bid for them and all sorts of stuff. It's great. And so you've got a completely distributed line. The reality is you guys are now on the front line, okay? So if you think about the Wild West, you know, I wouldn't have wanted to own a bank or a stagecoach, okay? Because they always seem to get hit. Yeah, cybercrime's the sort of, that's what's really ramping up. So there's sort of an example, there's credit card auction sites. And what's really interesting is after the Target hack, you know, Target, the retailer in the US, you saw all the prices plummet because of supply and demand. So they actually held the credit cards back because they didn't want to swamp the market. It's great, isn't it? You've got economics in there as well. You can do a degree on this stuff. We'd found a new online site the other week called the London Underground, and by the end of it, you have it literally a shopping cart, and you're selecting what you want. We had 2 9mm pistols, a bag of cocaine, and about 10,000 credit cards. So all you want for a decent Valentine's. But you know, these things are out there, and it's highly commoditized, and it's all payment via bitcoins because that's the reason why everyone uses bitcoins. So, you know, you have to kind of realize what's going on. So who's attacking you and why? Because there's some interesting reasons you need to understand. So the first thing is they want your customers. Now, they don't actually want your customers. They want your customers' resources. So this is where if I can inject something into your website, every single one of your customers is now potentially going to download malware, which means I can get their banking credentials. Thanks for that. So that's the reason why these high-profile sites are quite often attacked, so they can push my malware out, because it's very difficult for me to drive 100,000 visitors to my site every day because I'm just a cyber criminal. So I'm just going to use yours because you have 100,000. I may want your data, and this could be credit card data, could be PII, it's something that I can sell. Data is very sellable. Resources. So I'm a criminal overlord, you know, I'm there, I'm in a big chair. I don't want to pay that AWS bill. I mean, it just keeps on going up. So I'm just going to steal your resources. It's fine, and you can pay for it. So I'm going to want to actually just churn the CPUs and the memory and network cards on your machines, because it's a lot cheaper than me paying the AWS bill. IP, this is a new one that's starting to come out. We're seeing this kind of Ernst & Young kind of, you know, we deal with international mergers, are being targeted to steal that IP. If you know who's going to take over who, I can sell that information for a lot of money because someone can make money off the back of it. And also the other one is just cash. They do this, the whole brick through the window thing that doesn't work in the online world. Well, it's now they'll rock up and say, give me $2,000 or I'll take your site out for the day. So they have stuff that you want. I'm going to do this in a bit. We had a bit of a problem with the demo. I have half the demo left. Thank you very much to, and I've completely forgotten your name, for trying to help me at the back, but we couldn't. So I'll be playing around with this in a bit. Targeted versus Google Docs. Who knows what a Google Doc is? No? Okay, everyone knows who Google is. Okay, great, we're on the baseline. Right, Google's great because you can search for stuff, can't you? You know all those really complex search strings that you can put in to find stuff, you know, beyond when someone goes, I can't find it, and you go, look, if you just exclude this and do this, there's the results you want, because we've all had to do that. You can take that a step further and actually search for vulnerabilities. So when a vulnerability is announced, you will quite often find somebody will publish a Google Doc, which is a string in Google that allows you to search for that vulnerability. Yes, good, this is the right page next. So if you take this, I picked an old one, so we have to be slightly careful. I'm not going to show you a bunch of stuff that's new. I think this is about 3 or 4 years old. So this was basically a very popular plugin for ASP.NET, and it helped you doing logging and error management. Very, very popular. However, the instructions setting it up weren't that good. And the trouble is, if you misconfigured it, which happened quite a bit because the instructions weren't great, what you would wind up doing is exposing all your cookies in a file that I could scrape off the internet. So again, I'm an attacker, I've got Game of Thrones to watch, so I want to do this quickly. So I can just use a Google Doc, and now I have 11,000 sites that are potentially vulnerable. You're also seeing things like hacking tools now integrate in with this. So if I'm writing a hacking tool to make it more valuable, to make it more scalable, I'll allow you to put in a Google Doc string. So you'll put that in, I'll ingest that, I make a call out to Google, I then pull back the 11,000 results. I then iterate through those 11,000 results, making sure which ones of those sites are vulnerable. Then I'll go and compare it against one of those lists that you find. You know, the ones that say how much, you are the 700th most busiest site in the country. I compare it against one of those, so I can then stack rank all my results. Out of those 11,000, I can filter out the ones that aren't actually vulnerable, and then I can stack rank you in order of popularity. So when I get up in the morning, I now have a nice top 50, top 100 list to go and attack. So what you tend to find is there's kind of two different types of hacking. One is you run foul of a Google Doc. All I'm going to do is try and exploit that vulnerability, and I'm probably going to put something like malware on your site or take a server and put you into a botnet. I'm not necessarily interested in a more advanced attack. I just want to exploit this and do something. So the first thing to make sure is that you're protected against pieces like this. So the piece that I can't show is Harvester. So who knows what open source intelligence is? I find this fascinating. I looked it up the other day. I spent ages reading about it. So open source intelligence is nothing to do with open source. Okay. It's been around for years. I mean, it's literally been around for hundreds of years. It's around gathering information that's available in the open world and making conclusions. One of the most famous cases was in World War II when trying to bomb the bridges. It was very difficult to understand whether or not you'd actually taken the bridge out. It's very difficult. You're flying really high. You think you hit it. You're not entirely sure, and you can't send someone in to go and check. So they British intelligence worked out that they could track whether the bridges were being destroyed via the prices of oranges in Paris markets. Because if you bombed the bridges, you took the transport out, and the oranges were the ones that were being transported up, and you saw the price go up. That is classic open source intelligence, and they still do it. So Harvester is, and there's a lot of tools out to do this. What Harvester does, and this is one I can't show you because the Linux thing all died on me. The Harvester will basically go out and gather information off the internet about your company. So it's going to come back with all the available email addresses on there. It's going to come back with all the public servers that you have. It's going to map out all of your infrastructure as much as it possibly can and highlight things that may be of interest. So those internal aliases that may have crept out onto the internet, I can now start to use those in things like social engineering attacks. Some of them then also bring in things like data from LinkedIn as well. So I can now map out your company. They'll also integrate it with Facebook, because if I can see two people in the same company who also are linked together on Facebook, the problem is that chances are there's more trust there. So these open source intelligence tools will go out there and gather information about you. GitRob is another interesting one. Who uses GitHub here? Mm-hmm. This was actually written by, SoundCloud? So they're a German startup. They wrote this to protect themselves, and I would highly advise you to download it. So what it does is you basically put in a repository in GitHub, and then it spiders out to all the related ones, and it downloads a vast amount of information about that onto basically a database that's run locally. So you go and collect all the different repositories from GitHub, and then it runs analytics across them. So it'll say, look, I found 4 files here with nothing, 7 blah, 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 found, here we go. There are 6 findings, 5 findings, 1 finding. And what it's doing, it's scanning your code. And again, so I can't run this stuff live because it really just does show current vulnerabilities. Anyone spot that? It finds things like that. If you upload your EC2 access keys, it'll find it for you. I think the next one, yes. Anyone know what an RSA private key looks like? Yeah. These things are very easy to accidentally put into GitHub, and you have to be aware people are actively scraping it. GitHub is an open source tool, and I encourage you to use it as part of the security development lifecycle, which I presume you're all going to implement tomorrow morning when you get into work. There are a number of different versions on this, and some of the more advanced ones that we've seen, static code analysis that kind of help find potential bugs. It can also find potential vulnerabilities. Yeah, they're running that against GitHub now as well. So they're basically running static code analysis against GitHub. So actually, we think you've got a vulnerability here. I can now go and attack your site and try and exploit it. So again, as a hacker, there's a lot of code out there. How do I reduce the amount of work? Well, I just run it against GitHub, and then I find the 20 sites that may be vulnerable to a SQL injection attack, or maybe they've included, it's the other one we see, including plugins. So plugins is, to be honest, are a bit of a nightmare, or frameworks that you use. So if Windows has a vulnerability, they patch it and they automatically push it out, and it's all in the press. Same with Linux or Oracle. Or the trouble is, some framework that you've downloaded and using, if they have a vulnerability, how are they contacting you? Are they? Probably not. So what they'll do is they'll have a list of vulnerable add-ins or frameworks, and they'll scan GitHub for people still using them, because you've normally got things like version numbers in there. And now I know your site is using a plugin that's potentially vulnerable. Again, it's around trying to get this open source intelligence. Right, so who knows, so SQL injection, I presume you guys know what a SQL injection attack is. Okay, so at this point, lots of developers go, yeah, it's fine, yeah, I've known this for years. It is one of the most, so OWASP Top 10, which lists the top 10 sort of successful attacks against websites. SQL injection is still at the top. So it is still out there, and people still do it. Again, I'm shouting a lot. So the thing that you have to be aware of as well, it may well not be your code. So again, we see a number of vulnerabilities in the frameworks we use. So Django had a recent SQL injection vulnerability. WordPress has a lot of SQL injection vulnerabilities. So quite often, it may well not be your code they're attacking. You have to remember that a lot of the frameworks you're using will be having databases to store their own config, and quite often that's how they get in. And the reality is, if I attack your code in WordPress, I can get so far. If I attack WordPress itself, now I can own WordPress. Now I'm in a very powerful state. So SQL Map is a tool that automates the finding of this. And by the way, the demo gods have not been kind to me today. So if this doesn't work, I'm just going to go and drink another beer. Let's have a little look. Here we go. So this is some of you might be able to see this. So this is some SQL Map Statements. It's great for this. You've got things like levels, so you can make it more or less aggressive, because you don't want to trigger people watching you. So this is the other thing we're starting to find. The attacks are now not just attacks, they're also trying to circumvent the systems that protect you. So if you think about it, if you're a virus writer in this day and age, you actually have two jobs. The first job is to find a vulnerability that you can write a virus to exploit, okay, or malware. The second thing is you have to work out how to get round antivirus, because nowadays about 98% of PCs in the world are running antivirus. So if you're a great virus writer but can't get around the antivirus stuff, it's not going to work. We're finding now more and more systems like this, and SQL Map has it, but I haven't put it in this. You can actually do things like detect any form of IPS device in the way, and then it'll start crafting attacks that it thinks can get around that IPS. So if you're creating a hacking tool, actually not only just being able to exploit something, but also having intelligence in there to allow you to work around the security devices is very popular at the moment. So, in the first one, we're going to flush the session and set the current DB. Basically, with these tools, they'll basically store a bunch of information. You've normally got hundreds of different pieces that have to build up to get you the entire story. So it starts caching it so you can reuse that information. This is the piece I'm going to attack. It's got threads, and let's give this a go and see whether the demo gods are going to be nicer to me than they were earlier. I'd just hasten to add, the demo gods were so cruel, they broke the touchpad so every time I clicked, it would stay down and like randomly grab windows. It was not a pretty sight. I shouted at it. Hold on, I forgot to do this. No, let's clear that. Okay. Okay. So let's fire this off. So this is SQL Map, so it's flushing the current session. It's going to start reaching out. Now the first thing, I don't know if you can see it on there, here. So it's talking about a blind SQL injection attack. Who knows what a blind SQL injection attack is?
You don't get a counter.
Correct. So this is people think I know about SQL injection. It's easy because I shove in, select star from user, and then the UI shows me everything. The reality is UIs don't show you everything. The reality is the UI breaks. because the UI was going to show you a name and an address. It didn't expect half the database to be vomited out at it. So generally, it doesn't display them very well. So what you use, and by the way, it's just working out what backend database I'm using. What it does is it puts in pause statements. So it's kind of a Boolean true or false. But instead of replying to it, it just tells the database to pause. And then it knows that's true. So if you want to, for example, find out all the table names, you say, is the number of tables equal to 1? No? Great. Straight back. 2? No. 3. And when you get up to 26, it's going to the database pause 5 seconds, and the tool goes, it's 26. And then it'll go, right, first thing, have you got a table beginning with A? No? AA, AB, and start iterating through it. So that's the way most people are now doing things like SQL injection attacks. These attacks have come on a long way. I would advise you to go and read up about them. The other thing they're using is DNS to get data out. So most servers open DNS ports to the world because what could possibly go wrong? What you do, if you think about a DNS request, if you've got mysite.com, I can just append information onto that. It's really easy. I could append the table names. And then if I can basically point you at my DNS server, I can actually just harvest that information. So in each DNS request, actually your server is passing out small pieces of information, which I can then gather. So anyway, so we've gone through this. We're using blind SQL injection because the site isn't going to display the information I want. And it's basically worked out that I'm using a MySQL database of 5.0.11. Again, it's going to do that by sending in certain commands or errors it knows. If I know that the version behind had a particular bug in it, I might be able to execute that, or I might be able to detect that. So it'll go through and work out what database you're using. Let's say no to this. Do I want to skip? Yes, I want to skip, so that's a yes. Do I want to include all tests? No, it'll take too long. So this is now going to finish off. So these tools are designed to start understanding your website. They're not as basic as people think they are. Come on, demo gods, be kind. Here we go. It's still going. And in a moment, it should ultimately finish. But this is where, again, people are very blasé about SQL injection. This may well not be attacking your code. This could well be attacking the web framework that you're sat on. But the main thing to take away from these things are highly automated. So with things like, again, with SQL Map, I can include a Google Doc. So there's lots of Google Docs around. Show me every site that has a parameter of ID equals 1. Great. Let's go and take 10,000 of those and start jamming in a potential SQL injection vulnerability, because I'll then find out. So it's found a vulnerable ID. Do you want to keep testing the others? No. Here we go. So it's given me a whole bunch of information. It's told me that, what the database is. It's told me that it's vulnerable to thing. And can you see there? Do you see that appear? It did that. Do you see that? It kind of built up on the screen. It took a number of threads and went, is the first letter A? Is the first letter B? Is the first letter C? And when it got to W, the database paused for 5 seconds. And it went, first letter's W. Nice. And then it went on and went through this entire piece. So that's blind SQL injection at work. So we now have a potentially vulnerable site. I've got out the fact that I know what MySQL version you're using, what WordPress version you're using. Ooh, there we go. Hold on. See, it's not my day. Let me just copy that. And let's see whether we can paste that. So I'm now going to try and pull out the table. So look here, received, so 2. Now you should see in the, so 20. Right, here we go, received. So it's got 16 tables. Come on. Not now. There you go. So it's breaking that down, it's working it out, sending multiple threads, understanding and it'll iterate through every single database, except it won't do because it kept on breaking when I was in Starbucks. For some reason, the rest of the tables aren't coming back out. But you can see, because trust me, if you think hacking tools is just the ropiest code out there, they are so badly written. But anyway, so that, if I get it to work, would iterate through every single table name, and then we can just start going down. And this is what attackers are going to do. So it comes down to the question of what can you do about it? So, and really this is where we come in. So what we do is we basically put a mix of agents and appliances within your environment because we can't get through to the network level. And we monitor this traffic. We're going to monitor the network traffic. So like an IDS, we're seeing all the traffic flowing in and all the traffic flowing out. At the same time, what we're doing is we're taking all the log files as well. The reason why we do that is, to be honest, some attacks show up really nicely on the network and some attacks show up really nicely in the logs. It's kind of two sides of the same coin. So we pull that information in, and we also have a specific device that's tuned for HTTP as well, because traditional IDSs aren't that good at it. So we're monitoring this. We then take these security events and we move it into an analytics engine. So we currently sit, I think, at about 5.5 petabytes worth of security data. We bring in about 100 terabytes a day. And the analytics engine runs across that and will basically correlate these different pieces out. So unfortunately, you probably can't see some of this. But these are real events that we've basically taken. So we've basically spotted a MySQL concatenation SQL injection attempt. We're seeing people trying to enumerate through the columns. So we can take this, but the key thing with us is we then don't spit this out in an email to you. We have our own security analysts. So we have about 100 security analysts split between here and the US, and this gets triaged by one of our security analysts. So he's going to look at this, and and I hate to say it is generally all he, he's then going to start drilling down into it. So we can then look at the very specific events. So we can get down to IP headers, TCP headers, and we can effectively get into reconstructing the payload. And once we can reconstruct the payload, at that point we can start trying to understand when the attack happened, and also, quite often most important, what came out. So these are real screenshots, just redacted information. Basically, this is a concatenation attempt. You can see here, select email address from blah, blah. That's a fairly basic one. We see really advanced ones. So you'll get like a whole string of hex, and then that'll be passed down to the database with the command of basically, decrypt it and execute it. So it'll take something like hex, put it back into ASCII, and then execute it in the database. And ultimately, this is basically the piece that we then saw coming out. So the SQL injection attack was actually targeted at the sort of header that would appear on your website. And from that, this attacker was starting to pull out all the email addresses of the people within it. So the key thing to remember at this point is, at 3 o'clock in the morning, you now have a security analyst looking at this, triaging it, and ultimately, if it's serious enough, they're going to pick up the phone and phone you. So, okay, this server's being attacked, this is what's going on, and this is what you need to do about it. We don't do the remediation. We're not going to remote in and fix anything. We don't want your admin credentials, and you probably don't want to give them to us. But our view is we understand the security aspect of this. You guys understand the infrastructure. So between the two of us, we can work out how to get this solved quicker than any one person can do by themselves. So as I said, what we're doing is we're basically bringing in data. We're breaking in data from the web applications, log data, network incidents. We bring them into an analytics platform. We also have our own threat research team. So these are a set of guys who spend their lives discovering the great and the dark and the good on the internet. They work with a lot of government agencies, a lot of other large security companies, and we write all our own security content as well as bringing in third-party feeds as well. And ultimately, we have the Security Operations Center behind it. So I think that's about it from me. If you need to get hold of me, and we'll even get these emails, slides sent out, my name's Jay Brown, or my email jbrown@alertlogic.com. But thank you very much for your time.